Hey there, welcome back to the TSS Garage. I'm Zach Chrisman, undercar training specialist for Total Shop Solutions Training Academy. Today we're going to take a look at what we consider our weight class of balancers. This will be the John Bean B200 through 800 series lineup. Let's start out by explaining first, these machines only take care of weight conditions in this series of the lineup. Other than the way the machines accept or maybe obtain dimensional data, maybe touchscreen versus buttons or a threaded shaft versus a power clamp, the operation and the user interface is largely the same. Let's go ahead and select the wheel and appropriate tooling we need for this application and get it chucked up. We have here an OE wheel, small passenger car wheel assembly. It is hub-centric, piloted on this vehicle, and for that reason it needs a collet. Actually needs a collet for more than one reason. As you can see here, there's a machined lip on the face side of the wheel that accepts a hubcap. That is relatively shallow, and if we don't use a collet, we run the risk of penetrating this bore too far and getting hung up on that inner machined edge rather than the machined edge that holds or bears the load of this wheel assembly. We would never want to front pilot this wheel assembly here off this machined lip due to the fact that that's not how it goes on the car. Using either a pin plate or pressure cup to get your assembly mounted to the balancer, make your selection. Remember, a pin plate is always going to be a little bit more accurate just due to the fact that you're more closely emulating the mounting process on the vehicle, and that's always going to be better. The pressure cup itself, you're going to want to use the protection ring when dealing with anything painted or an alloy. No protection, just hard plastic would be the preferred method for a steel wheel. Next, select your collet. We have our collet here, which we're going to size it up and make sure it's a good amount in there. We don't want to just nip the shoulder of the outer edge. We want a little bit of penetration, but not so much that you're going to get into anything else. Let's go ahead and get this guy mounted up. On balancers equipped with a SAPE arm, we're going to use the SAPE arm itself to obtain the dimensional points that we're applying our ALU2 plane sticky weights to. Simply touch those 2 points, close the hood, perform your check spin. If we're doing a nail-on configuration, all we would have to do is touch that rim profile's edge, and in the event that we have that sonar sensor, that's going to pick up that second data point as we close the hood. If your machine does not have a sonar sensor on it, then the width will be the last data point only that we enter. Once we're satisfied there, let's close our hood, perform our check spin. Once we've done our initial spin, I like to start on the inside plane, highlight your plane, and on a balancer equipped with a SAPE arm, we're simply going to pull back on the spring-loaded collar and put our weight that is being called out in that collar. So I'll peel back our adhesive. I'm going to center as best I can our weight in that holder. And as you'll notice, as I move this arm out with the inner field highlighted, it's going to count down on the screen to 0. As we get down to 0, it's going to beep, and I can use the application trigger here on the spring-loaded collar to apply the sticky weight. And what I've done is I've applied the sticky weight exactly where I told the balancer that counterweight positioning was going. A lot of times the perception is we should apply that at 12 o'clock. The point of the SAPE arm is so that we're more precisely pinpointing where our dimension counterweight's going to go. Duplicate the process for the inner plane, and you're good to do a check spin. Once you're satisfied, close your hood, perform your check spin. We're good to go. Some of the other features that are available to use are fairly intuitive to use still. We're gonna show you how to use behind the spoke or hidden weight mode. Simply tell the balancer how many spokes you have in your wheel assembly, position a spoke at 12 o'clock, and then enter the mode. As you can see, it'll split that outer weight plane for us simply by selecting one of those highlighted edges. Again, use your SAPE arm to apply your weight. You'll get a countdown, and in this case, it's right behind one of the spokes. The other feature I want to point out is going to be just simply static mode or fine resolution mode. So if I want to go into a single plane or static balance and maybe look at residual round off amounts, I could just hit F4 in this case, or in a touchscreen case, you would just touch that center static number. And then the magnifying glasses is going to be your residual round off. So in this example, we have 0.05 of an ounce, almost nothing. This thing's gonna be absolutely perfect. That pretty much does it. Let's go ahead and move to a more automated B800 machine in this lineup and show you some of the features on that. Moving into the B800 balancer, it's a fully automated data acquisition machine. So there's no need for any user input, which is a huge benefit to anyone trying to eliminate silly errors. One thing to note, if your balancer has a designation of L, that stands for laser. That means it will have a laser pointer in lieu of a SAPE arm. If it has a P, it also has a power clamp. So it'll have a laser and a power clamp. Power clamp is a fantastic way to, again, eliminate centering errors and duplicate the mounting process. So here I'm using a speed plate, which is not only super easy, but highly accurate. Clamp our wheel assembly, and in this particular model, simply close the hood. There's no reason to put any other data points in. The machine's gonna gather all that for us. There's gonna be a laser that scrolls across the wheel's profile, taking into account the counterweight positioning, as well as a laser that counts spokes automatically. Once we've done our initial spin, we can now go into what features we want to use on the machine. In this case here, we've got no weight to deal with. This wheel assembly's already been balanced, but as I move into that inside plane, you can clearly see here the laser pointing right at the plane where we need to apply the weight. So in a situation with a laser, where I would apply this weight would be just like that. Right on the edge and right centered with the laser. Other features are going to include the ability to move your inboard plane. So maybe you're in the salt belt and you don't like this inboard plane here that the machine has selected for you to call out your weight. Well, simply touch the laser movement indicator, and by turning the tire, I can scroll that placement of weight to a different dimension. And when I'm happy with it, I'll just press it again. It'll lock that data in, and any dimensional changes that changes weight will automatically compute in the machine. Balancer's got a nice backlit scenario so we can see what we're doing, and then we can easily in the screen switch between single plane and static or dynamic two-plane modes. Clicking on the magnifying glass here, I'll be able to go into a residual round off or actual weight. And again, if I want to split my weight, I just touch on the split weight here, and you'll notice that that plane has already been set up for me. So in this case, it's behind the spoke, and then I can move to the next spoke, and again, it's behind the spoke. So what a great way to hide weight on a 22, 24-inch wheel, and you don't have to, you got all that real estate and you got a huge chunk of weight right there. That pretty much sums it up. If you guys have any questions at all, please reach out to us. We'd love to help you. Thanks for checking us out, and we'll catch you on the next one.